What's up, everybody? So it's good to see you, Mr. DeFazio here. We are going to be teaching you about the three states of matter: solids, liquids, and gases. Can somebody give me an example of what a solid could be?
Dirt.
Dirt?
Rock.
Rock is better. I like rock better than dirt. You could say dirt is technically a solid, but I do like rock. So let's go ahead and make sure everybody has their science notebooks out. Okay? And I want us to create 3 columns here. So just draw a line right down your paper like that. Go over just a little bit, draw another line right here, and we're going to write solid in the first category. We are going to write liquid in the next category. And what was that third one I said?
Gas.
Gas. We can write gases in the final category. And I believe we heard, what was a solid again? Could you repeat that?
Rock.
Rock is a good one. I like rock. Can anybody else give me a liquid?
Water.
Water is a good one. I like water. Would soda be considered a liquid?
Yes.
Yes, okay. What about a watermelon? Would that be considered a liquid?
No.
And why would watermelon not be? It water's in the name.
Because it's hard.
It's hard. I like that. Yeah, because solids are hard. What about a gas?
I don't know.
You don't know? You know, Mr. DeFazio actually had a birthday. And you know, his birthday, my birthday is in March 1st actually. And during my birthday, my fiance got me a balloon. Now this wasn't just any ordinary blow-up balloon. She got it from a store, and when I inhaled the balloon, it makes my voice really squeaky. What is that? It's called helium that's in the balloon. Would that be considered a gas that's put into that balloon to make it blow up like that?
Yes.
Yes, it could be. You know what else can be considered a gas?
Air.
Air is considered a gas, right? Okay, so we can put helium, and we can put air. We can put that. Now, I'm going to make this really cool for you to recognize this. I really want us to really understand the differences between solids, liquids, and gases. Did you know that in all matter, in these 3 states of matter, there are little tiny microscopic, even Mr. D's glasses couldn't see that close. The tiny little things called molecules. And when these molecules group real close together, they make a solid. So like, how close do you think molecules are when they're in, like, say, a rock?
Super close.
Super close. It's a word called compact. Can you say that with me?
Compact.
Yes, that means they're tight, they're close together. What do you think the molecules look like when they are in a form of water? Let's say water, a liquid. Do you think that they're kind of spread out, or do you think they're way spread out?
Kind of spread out.
Kind of spread out. When would molecules be super spread out?
When they're gas.
When they're gases. Do you guys know why that is? It's because the air around us is so immense. There's air everywhere, so they have to spread all the way out. So when they're in a solid, right, when they're grouped together like that, it becomes A solid. Good job, guys. Okay, so we are going to be recording an experiment. So why don't you get a clean sheet of paper out? You're not going to use it right now, but Mr. D has a cup of water, okay? So we have a cup of water here. We have a cup of ice. And we have a Batman mug. The mug is empty. I'll tell you what we're going to do with that here in a minute. First, I would like to tell you guys that, you know, in Genesis 1:1, God tells us that He created the heavens and the earth. All things are created by God. And it's really important for us to make these discoveries because we can stand just amazed at how cool things are that God made and how they can change, and it's so interesting for us to learn from that change and to watch it and observe it, and then we can truly worship God's handiwork. Okay, so the first thing we're going to do is we're going to look at this ordinary cup of water. And this would be considered a, what is this again? I totally forgot. What is it?
Liquid.
It's a liquid, okay? So if you can imagine right now, there are molecules all in these liquids. And what are they doing? Are they close together?
They're kind of close together.
They're kind of close together. They're just kind of like, I like to think of this. Everybody kind of wiggle. Are you wiggling? It's kind of like moving with the ocean. They're just kind of moving around in there. They're free to roam. Okay? Actually, we can use this for a solid. This is a solid, correct?
Yes.
Now, not a lot of wiggle room for the molecules, is there?
No.
Right. So it's compact. They're walking around like this. They can't really move anywhere. They're just stuck in place. Okay, and then we have this cup of ice here. Okay, so if you guys want, what we're going to do next is we're going to put this ordinary glass of water. Now, what do you guys think is going to happen when Mr. D puts this into the microwave? Yeah. What do you think is going to happen when Mr. D puts this into a microwave?
It's gonna get really hot.
It's going to get really hot. Did everybody hear that? That is right, because the microwave makes things hot. When we are going to add water, this cup of water, to the microwave so that we can see what happens. Now, Mr. D is not going to put a glass cup into the microwave. That's why we're going to use this mug here. Okay? We are going to pour the water into the mug. Alright, so in your science handbooks, go ahead and write water. Write water at the top, and then I want you guys to put a plus sign and to draw whatever you want that represents heat. So what could represent heat?
Fire.
Fire, that's what I was thinking as well. And we're going to see what happens to the water when we put it in. How long should I put this in?
2 minutes.
2 minutes, okay. We are going to put this in for 2 minutes. And as we're doing that, as that water's heating up, what was this again?
Ice.
Ice, okay. So, what can you guys tell me just from looking at this glass? Let's observe it. This ice has been sitting out for a while. What can anybody notice about this ordinary cup of ice?
There's water at the bottom.
There's water at the bottom. Really? What do you think happened to that?
It melted.
It melted, right? Now, what do you think happened? What is ice? What is ice?
Frozen water.
Frozen water. So you took a liquid and what did you do to it?
You froze it.
Yeah, I didn't melt it, I froze it. So if I were to put this back into the freezer, what do you think would have happened?
It'll freeze.
It'll freeze, right? Does anybody notice something else about this glass of water? I can see something.
There's water on the outside.
There's water on the outside. Why do you think that is?
It's sweating.
It's sweating, right? Well, there's a big old word that we call this in the science field. Condensation. Can everybody say that?
Condensation.
Right. It's condensation. So what's happening is all the water particles, that are covering this glass right now, when you put an extreme cold or an extreme hot around it, it causes it to have condensation, and that's why we get this wetness on the side. Whoop. That tells us that this is done. Let's pull this off. We're going to be very careful. Now, I don't know if anybody can see this.
There's smoke.
Smoke, right? It kind of looks, we actually call that steam. Do you see that?
Yeah.
This is also part of condensate. This is so cool to watch, because what happened is when the liquids are heating up, what do you think's happening to all the liquid right now?
It's smoking.
Yeah, or it could be lifting, it's rising back up, right? Now, all right. What do you think would happen if I covered the coffee mug with a piece of paper towel?
I don't know.
You don't know? You want to find out?
Yeah.
All right, let's find out together. Put it down like this. All right, let's lift up a little bit. Can you feel that?
It's wet.
It's wet, so it's turning back into what?
Water.
Water, which is also what have we been?
Liquid.
Yeah, absolutely. It's turning back into a liquid. See, guys, everything becomes a cycle. It's a cycle. So what we see here is a cycle being formed whenever we add cool or heat. Okay? What do you think would happen if we put this glass of ice into the microwave?
It'll melt.
It'll melt. That'll be really cool to watch. Let's go ahead and watch that. We won't put it in for 2 minutes. How's about not 2 minutes? What should we put it in for?
1 minute.
1 minute. Let's try 1 minute. This is a glass of ice. Okay, so now that we just got done with the glass of water, I want you to put in that water plus heat equals, now we know it's not smoke. What was that other word I said?
Steam.
Steam, which is a
Gas.
gas. Okay. Alrighty. So, now I want you to put down ice, and I want you to put heat and an equal sign. And then what did we think it was going to happen to the ice?
Melt.
Melt, which would then turn the ice into
Water.
water. Okay. Did everybody get that? All right. Let's go ahead and look at this now. Whoa, look at that. You guys see it? It's actually dripping. Look inside there. Do you remember how big and blocky the ice cubes were?
Yeah.
It's now turned into a liquid. Now what Mr. D is going to do is we're going to go ahead and put this into the freezer for right now. And now I want you guys to put down, this is our final discovery. What did Mr. D just do? I want you guys to tell me what we're going to be writing down in our books.
Water plus cold.
Equals
Solid.
solid. Okay, so what would we put down besides water though?
Liquid.
Liquid plus,
Heat.
no, liquid plus
Cold.
cold equals
Solid.
solids. Okay. Now, this happens in our everyday world and weather. Okay? So when those big old clouds get filled with water and condensation and all the gases from all the heated water goes up to the sky and it collects in these big clouds, what happens when it puts all that water out? What do we call that?
Rain.
Rain, right. Now, what happens when rain cools? It becomes
Snow.
snow. So we don't really need to even see it like this. We can see these changes, these 3 stages of matter in every aspect of our life. How cool is that? Okay, so it's only been in there for a little bit, but I'd really like to see what we have here. Okay, so we haven't seen much change here, but if you notice from looking at it before, the ice seems to look a little bit harder. And can anybody tell what else happened just for that short time that I put it into the freezer?
The glass got cloudy.
The glass got cloudy. That's right. Now, and what does that mean? So what was that big word I said earlier?
Condensation.
So the condensation, right? That's why it's not all dripping wet. It started to cool and now it looks cloudy. So that's pretty cool looking. All right, we're going to put this down. So, now after this, we would do our assessment, and what I had planned for the assessment was something called the molecule game. I thought it would be really cool to integrate this with the students. So what it would entail is I would tell the kids to stand up, get out of their desks, and I would yell out either solid, liquid, or gas. And the students, using their bodies, would, if I yelled solid, we'd all run together and get real close together, and they can't move, right? Because solids are so tightly compact. If I were to say liquid, they just kind of go around the room, not really touching each other, arm's length apart, and they would just move with the ocean. If I said gases, they would all be reverberating all and spread all the way out around the classroom. And then after that, we would go on to the next step. So the next day, we would start looking at each one more closely. So this would just be simply a overview of the 3 stages of matter. And for the next week or so, I would be teaching them about solids more closely, liquids more closely, and gases more closely. So, thank you.